place walls, it is easiest to do so in a floor plan, so let's switch to the first floor plan. To see more detail, we will turn on the thin line view. Let's also choose Fine as our detail option. Walls are placed using the location line as a reference. This option chooses which part of the wall will be placed over the line we draw. As you can see, as we create this wall on the edge of the slab, we are drawing where we want the wall center line to be, since this is our location line. If we switch the location line to finish face exterior, we are now drawing where we want the outside of the wall to be located. Once the wall is placed, we can select it and give it a new location line in its instance properties. However, this does not change the wall placement. It only changes the location line for future wall edits. For example, if we switch the wall's orientation, this uses the new location line, not the initial one used to place the wall. There are other instance properties that also help modify our walls. We'll use an elevation view for this example to see things more clearly. The base constraint allows us to choose where the bottom of the wall will attach to. The height is still set to the default value of 20 feet. We can also give the base an offset if we want it to begin in between levels. Next, we can change the top constraint from unconnected, which uses a specific height, to a chosen level. As with the base constraint, we can also give the top constraint an offset from its assigned level. To change a wall's structure, we must edit its type properties. In the Structure dialog, we can see every layer that comprises the selected wall, as well as the function of the layer, what it is made of, and how thick it is. We can add new layers, delete layers, or edit layers. Let's give the outside layer a new material. Change the old material from brick to wood shakes. Here we can also change the surface pattern if we want. After selecting OK, this new material now appears in our model. Since we did not create a new type, let's return the material to its proper selection. Now, notice the option of wrapping. This option is also available in the previous dialog. By selecting wrapping, we are choosing what material to use for the ends of the walls. Now, notice that the brick is wrapped all the way around the wall, including the sides and top. By using the interior as a wrapping, the interior material wraps around the edges of the wall. To add design features to the wall, we must once again edit its structure. However, notice that the Sweeps and Reveals option is grayed out. To change this, preview the wall and change its view. Now let's add a sweep, or an architectural extrusion that runs along the wall. Select Add to create a default sweep. From here, select a new profile, or load one in from the library. Now, select a new material for the sweep. Now, we can choose a distance measured from a base location where we want the sweep to be located. When we are done setting the properties and adding sweeps, select OK. Our new sweep will now be displayed in our preview wall. We can also see the new sweep on our walls in the model. By repeating this process, we can add additional sweeps to a wall or edit existing sweeps. When finished setting the properties of the additional sweeps, we can select OK, and the new sweeps will be displayed within our model. To add reveals, or reliefs that extend across the face of a wall, we can once again edit the wall's structure. By undergoing the same process we used to create sweeps, we can create reveals at specific distances from a base location. After selecting OK, the reveals will be displayed along with the sweeps in our model. Stacked walls are a combination of two walls and can be selected as a wall type. They are also placed the same way as regular walls. When selected, we can also choose instant properties like the top constraint, like we do with standard walls. Now let's select the wall and edit the type properties. In the structure of the wall, we will see that the wall is comprised of two different walls. By changing the offset, we can choose how these two different walls line up, and the effect will be seen in the sample preview. In this dialog, we can also choose which wall types we wish to be stacked. We can also edit the height of the bottom wall, and the top wall remains variable. By selecting OK, we can see these changes in our model. Now, let's edit the existing stacked wall and duplicate its type to create a new wall. We will call the new wall Brick on Concrete. Now we can edit the structure choose a brick wall as the top wall and a concrete wall as the bottom one. Next, let's align the walls by choosing an offset and when finished, we can select OK to see our new wall type in the model. Since this wall type is simply a combination of two other types, a change to the other type will have an effect on the stacked type. For example, let's add a sweep to the concrete wall type used in the stacked wall. Select the concrete wall used and edit its type. Now we will add a sweep to this type. In the model, we can see that by adding a sweep to the concrete wall type, it also appears in the stacked wall that uses the concrete wall type. After selecting a wall, we can also edit its profile. This opens a sketch of the wall's boundary lines. Using the drawing tools, let's create new boundary lines and then finish the sketch by selecting the green check mark. As you can see, we now removed the top corner of the wall. By creating a sketch within a wall's boundaries, we can create holes. We can also create holes using the wall opening tool. However, using this tool, we can only make rectangular shapes. After selecting the wall we want the hole to be placed in, draw the rectangle and the hole will appear. For this tutorial, we will use this unfinished two-story model to add some doors and windows. Let's first switch to a plan view. Open the Windows tool, select and type and add some instances into the model. The windows are directional, and the sill will be placed in different locations depending on what side of the wall you hover the cursor over. When placed, each window has a tag which helps identify the type of window used in the model. This is really helpful when schedules are created. We can now switch to a 3D view to see our windows in the model. Back in a plan view, we can select a window and change its temporary dimensions in order to give it a new location. The window that is selected is the window that will be moved to satisfy these new conditions. Using the Aligned Dimension tool, we can set lengths between the walls and windows. When finished, we can select the EQ equal symbol in order to equally space the instances. Once again, let's switch to a 3D view to see this change. As I said before, each window is directional, and the orientation can be changed by selecting the window and then choosing the little blue arrows. By doing this, we are relocating the sill to the other side of the wall. This change is also noticeable in the 3D view of our model. We can place windows quicker using the array option. First, let's switch to a plan view and then place one instance of a window. Now, select the window and choose the Array tool. For now, uncheck Group and Associate. Change the number of instances to 6 and leave the Move to Second option as is. This will let us place the second instance, and all other instances will be placed at the same distance from the previous one. Select a reference point in the new location in order to create the array. In a 3D view, we can now see our 6 equally spaced windows. Now select the window and let's try to array it again. This time, set 8 as the desired number of instances and choose Move to Last. This will let us place the last instance, and all other instances will be placed within the 2 and will be equally spaced. In a 3D view, we can see the array of our 8 windows. Now, let's array the window but select the Group and Associate option. After we place the last instance, we are now given more options since each instance is considered to be part of a group. We can select a window and change the desired number of instances. Or we can select a window and choose to edit the group. In this mode, everything we add to the window or delete will be added to every other window as well. For this example, let's add some decorative railings around the window. We can see the railing in the 3D view. Now let's select it and move it up a few feet. When we are happy with the railing, we can select the green check mark and the railing will appear on every other instance in the array. Once a window has been placed, we can also change their properties. As an instance property, we can change the level that they are based on, changing from the first floor to the second floor. Also, we can change the sill height, which is the distance above the base level that the sill is located. When changing the sill height, notice that the head height automatically changes since the height of the window is a constant. In the instance properties, we can also change the window's mark, which will help later with identifying windows in the model. We can also edit a window's type properties in order to create even more variation. Let's start by increasing the width of the trim. After selecting OK, we can see that every window in our model of this type now has a thicker trim. In the type properties, we can also do things such as change the window's materials. Let's change the trim material to be metal. Once again, every instance of this type is affected by this change. Now, let's change the location of the window sill. This new dimension determines how far in the window pane is set. In a 3D view, we will notice that we have pushed the window sill in. Finally, let's create new dimensions. To do this, we will duplicate an existing type and give it a descriptive name. Next, we will change the dimensions of this new type. Once we click OK, the window selected will change its type, and the new type can also be found in the Type selector. Doors have similar properties to windows. To begin this example, let's start by placing a door into our model. After placing the door, we can select the blue arrows to change the direction of the swing and where the hinge is located. We can also select the door and give it new temporary dimensions. Also, using the Align Dimensions tool, we can assign dimensions to the door, and we can select the Equality EQ symbol in order to equally space the measurements. We can break this constraint by assigning new temporary dimensions and choosing to remove the constraints. In a 3D view, we can see our new door. Similarly to Windows, we can select the door and change its instance properties or its type properties. We can also duplicate the type to create a new door with new dimensions. When finished with the desired edits, we can select OK to see the changes. We can create wall openings in various ways. First, let's place one as a component. If the wall opening type is not available, we can load it in as a family from the library. Now we can select the type, and it will be available as a component. Find the new type in the type selector and place the opening as if it were a door. In the 3D view, we can more clearly see our opening. If we do not like the shape of the opening, we can select the opening and edit the family. From here, we can select the opening and edit its sketch to create a new opening. When finished with our sketch, we can save our design as a new family to ensure that we do not overwrite the existing family. When finished, load the family into our project so it will be available for us to use. If desired, select the existing opening and change its type to the new one that we just created. We can also create wall openings using the Wall Opening tool. Select the wall we wish to add the opening and create the hole. This technique limits us to rectangular shaped openings. To create a roof, let's go to a plan view and open the Roof tool. Now we can create a sketch of our roof boundaries by selecting walls. We can select the green check mark to finish our roof. In this dialog, select Yes to attach the walls to the bottom of the roof. In the 3D view, we can see our new roof with default properties. After selecting the roof, we can make simple changes by editing the footprint. When selecting a line, notice that we can change its overhang and slope. We can also select all the lines and change these properties at the same time. Let's increase the overhang by 1 foot and decrease the slope to 4/12. We can also edit the actual footprint by deleting lines or adding new ones. When finished, select the green check mark, and our 3D view will reflect these changes. We can also change the roof properties after we have selected it. If the roof is in the wrong place, we can give it a new base constraint. We can also select the roof and change its type. Instead of using default properties to create roofs, we can change the slope of the boundary lines, or we can choose not to assign slopes to boundary lines in order to create a wide range of roof shapes. Start by making a flat roof by selecting all the boundary lines and removing their slopes. When finished, let's return to a 3D view. And from here we can see our new flat roof. Once a roof is placed, we can put in voids, openings, or skylights. Edit the roof's footprint and draw the desired shape of the ceiling hole. Finish the sketch in order to see the completed hole. We can also make a void in the ceiling using the vertical opening tool. Select the surface to place the opening, and then sketch the opening. Finally, we can place an actual skylight. If the skylight component is not available, we must load it in from the library. Under Windows, we are able to find the skylight component. Once the skylight is loaded into the project, we can select that type and place them on the ceiling as if they were windows. Using this method is good because it creates voids and adds the windows and trims all in one step. Now let's experiment with more shapes by making a shed roof. When editing the footprint, remove all slopes except for one. When finished, select the green check mark, and we can return to our 3D view to see our new roof. Now let's see what happens if we change the wall that we have defined a slope for. In the 3D view, we can see that whatever edge has been assigned a slope will project that slope in both directions. In this case, this leaves us with a small wall on the south side of the structure. Now let's create another roof shape. By assigning a slope to parallel boundary lines, we can create gables at the ends of the structure. When finished, let's switch to a 3D view to see what this looks like. Now let's fine-tune the roof edges. Select the roof and review the construction type properties. We can change the rafter cut or the depth. Let's start by changing the depth. When finished, we will notice that this decreases the depth of the edge of the roof. Now let's change the rafter cut to 2-cut square. Notice that the edge is now at a 90-degree angle with the bottom of the roof. We can see this better if we increase the depth again. Now the 90-degree angle is very apparent. Next, let's change the type to a plumb cut. Now the edge is perpendicular to the ground. For this type of cut, it is not necessary to enter a fascia depth. Finally, we can choose whether we want the roof to be made from rafters or trusses. To demonstrate the next feature, let's start by giving two edges different overhang lengths. In a 3D view, it is obvious that these two eaves don't line up. To fix this, select the roof and edit its footprint. Now open the Align Eaves tool. Choose the line to use as a base point. Then select the boundary line you wish to be moved. Now we can see that the eaves line up properly. With the Roof tool, we can also do things like add fascias and gutters. To do this, we can select the tool, and then we will choose the edges we would like to place the gutters on. To create a new roof type, we will start by duplicating an existing one. Let's first select the roof and edit the type. Duplicate it and give it a new name. Let's make a Spanish tile roof. Now select the structure. We can now see each layer of the roof and its material. Let's select the finish layer material in order to create our new type. For this example, we will duplicate an existing material. And let's call this new material Spanish tile. Next, select this material, give it a new surface pattern, and assign it a color. When finished, we can see that our new type has been applied to our model. Using this structure, let's create a roof from an extrusion. First, let's switch to an elevation view to draw a work plane. This line symbolizes the edge of a plane that is going into the screen. After we draw the plane, we can select it and rename it. Now, let's open the Roof from Extrusion tool. Then, find the plane that we have just created. This will allow us to draw on the plane. Switching back to the elevation view, we can now sketch the desired shape of the roof using any of the tools. When finished, we can select the green check mark to complete our sketch. In a 3D view, we can see that the line has been extruded across the whole structure. Now we can select all the walls, and choose to attach them to the new roof. If desired, we can select the roof and change its roof type, or we can select it and choose to edit its profile. When finished, select the green arrow again, and the changes will be applied to our model. Finally, we can select the roof, and we can extend the boundaries if necessary.